Alright, let's look at the practice exam 1, problem number 6. Alright, so we have a spherical tank with radius 3 meter. Alright, so I'm going to just draw a picture. So here is the x-axis, and here's the y-axis. Alright, so I'm going to just draw a circle with radius 3. So here's a circle to represent the profile of the spherical tank. Whoops. Let's see if I can do this. Right, so we have a circle. Right. Then radius is 3. So 3 is here, and negative 3 there, and negative 3 there, and a positive 3 there. Alright, then let's see, we have 1 meter long spout, so it's going to be at 4 there. So you have that. Alright, then we want to pump the water out through the spout, which is 1 meter long. Alright, so let's find the amount of work required to do that. Alright, so first I'm gonna start with maybe some random yi star. Alright, then think of like a disc of water. So you have kind of a disc which looks like that. Oops. Right. Alright, so disc of water. Alright, so let's use the width delta x. Alright, then the equation of the circle with radius 3 would be, so using a circle, so you have x squared plus y squared is equal to 3 squared. So I'll just say 9. Alright, then in order to find the radius, which is from here to there, right, that would be the x value. So I'm going to solve for x. So this is going to be subtract y squared. We get x squared is equal to 9 minus y squared. Alright, then we can take the square root of both sides. So x is going to be plus or minus square root of 9 minus y squared. Alright, so radius is just going to be square root of, so square root of 9 minus y squared. Alright, so let's find the volume of that piece. So this is the piece right here. Right, so this disc full of water. Right. Alright, so volume, I'm gonna call it the V1 VI is going to be. Alright, so this is a circular disc, so pi radius squared. So pi radius is a square root of 9 minus y squared times the width is delta y. Actually, I wrote delta x, didn't I? So this, I meant this is delta y. Alright, so that will give you the volume of the disc of water. Alright, then if you want to turn it into the force, we can multiply by its density. So it's a force, I'm going to call it the F sub I is going to be density, which is given to be 9,800 newtons per cubic meters. So we're going to multiply by 9,800, and the volume is pi, and we can simplify it as 9 minus y squared and delta y. right? Well, maybe I should say I star, right? Then we want to find the piece of work required to lift just one piece and up to 4. So if you want work, all you have to do is take the force 9800 pi 9 minus yi star squared delta y. Then the distance it needs to travel. So it's just the distance between yi star and 4. So this is going to be 4 minus yi star. Alright, then we can just turn it into a total work by using an integral. So this is going to be, work is going to be, alright, so y is going to go from at the bottom, which is -3, and at the top, +3, right? Then you have 9800 pi, so that's just a number. And then we can just strip off I and star, so you have a 9 minus y squared. And I'm going to put 4 minus y first, right? And delta y becomes dy, right? So this represents the total amount of work required to pump all the water out of the spherical tank, out of this through a 1 meter spout. All right, that's it. I hope that this was clear.